Okay. Yeah. So today we are gonna cover paper title self-refine. So at least as per the paper, right? The idea at least is that you improve the model, like let's say the base model with the same model over time. And here in this case, there are two ways, right? One is where you actually update the model parameters, like where gradually over time and improve the model. And next is you just let's say whatever the output that you get, right? You just refine the outputs basically over time, and that's how you do self-refinement. So here, there is like second approach that is you gradually uh, iterate over the model outputs and try to refine it based on the feedback. And in this case, it does not require any sort of like supervised training or at least data as well, because it's all everything is done in place. So yeah, that's one advantage of this approach. And to give you a broad overview, they try it on seven different tasks, which are like more generative tasks, uh, which focus more on, let's say, dialogue, where it's multi-time response, mathematical reasoning, and many more like contextual understanding and common sense understanding tasks over like very good models such as G3, 3.5, and G3.4. And as for the performance, it seems that this approach improves the performance by approximately 20% on an average across like all tasks. Yeah, feel free to interrupt the discussion. And as we know, right, the language models are much bigger as well over time, and plus they can generate text which is more forwarding. But still, they tend to struggle, let's say, in cases where, uh, let's say, it's something which is intuitive or it is hard to define goals, such as like enhancing program readability, or like maybe cases where like you require multifaceted, let's say, uh, how do you say, like objectives where, for example, you need to improve across like 10 different, like, let's say, aspects while generating response, right? So there, the models cannot get the response correct in the first shot. And that's one of the, uh, like, let's say, draw, so, potential area for improvement, like of the current models as well. There are a couple of approaches where, let's say, people have tried refinement, and those are actually refinement where they actually train a model, like another separate language model, which takes in, let's say, this old output and then applies some refinement or at least generate a refined output. And similarly, these approaches are very expensive because you require expensive training data, right, of such type to actually, like, let's say, train this refiners, right? And the other approach is like RLHF based approach, right, where you train a reward model and like let's say you generate n different trees, uh, outputs and do preference modeling, right, based on the server. Mhm. So if we look at it figure one, right? So that's the overall algorithm of the paper or at least the idea, right? So you start with the input, you pass it to the model, you get some output. And once you get the output, you pass that output to the model and ask it to generate a feedback. And based on that feedback, you again, let's say, pass this original output feedback as well as, let's say, the input to the model, and then ask the model to just refine it. And you do it iteratively over time, like over different steps, and until you, let's say, get the desired output. So that's how the algorithm works in principle. And it is like, let's say, the number of steps, right, or at least iterations we need to do refinement. That that can be like based on some, let's say, threshold, like maybe you do it for n steps, or probably like some other criteria where you, let's say, once you get some desired output, you just stop it. So something like that. And at least let's understand why is this problem important or at least interesting. So for example, right, if you look at the examples which are highlighted in red, so if you're writing an email, right, maybe you might write like first draft, which is, let's say, not very polite, right, when you're writing to colleague. So you might want to like basically rewrite it, right, or at least refine the, let's say, initial draft, right? And similarly, when you write code snippets, right, you first just try write a code snippet without worrying about like documentation or at least any other things, right? You just want some quick solution for the stuff, and then gradually you try to refine the let's say code, right? Once you this reassure it over time, right? So those are like I think two examples that kind of gives you idea why refinement is why like let's say refinement is like let's say part of the process in our day-to-day life as well for most of the tasks, and how similar process or at least the idea can be applied to LLMs like for improving the outputs. And you mentioned already that they tried on seven generation tasks. We'll shortly see which tasks are those and yeah. So now coming to the let's say the algorithm, right? Or it is the process, right? Like that is followed. The first part is like you have some input text, right? Like as you input prompt, right, to the query to the LLM, and you want a LLM to generate an initial draft response, right? So in this case, you basically have like let's say input text and a prompt like uh, for generation, and you prompt the model with this two concatenated inputs, and then expect the model to generate an output. So that's the first step. The second step. So in this case, like whatever we will talk about right now throughout the paper, like all the stuff you start prompting, similar to GPT 3, GPT 20. And next is like the second step is generating the feedback. So like you now already have the let's say input X as well as the initial draft Y sub T. Now you let's say want to generate a feedback, right? So you basically concatenate this with feedback prompt and basically ask the model to generate a feedback. And in let's say feedback, right? Like feedback also, we'll see shortly like how the feedback prompts are. But in this case, like feedback can be like let's say more of like a textual format or at least also multifaceted where you ask like model to let's say generate or at least theoretically like let's say review the output across like X aspects that you are in of interest, right? So and here the idea is that the feedback is more actionable or at least some points, right? Which kind of like gives you let's say a hint, right, about what areas or what, like, let's say, portion of span of text to improve it. And then basically the next step, the model will take this and input and try to improve that, like, let's say, particular concern, right, that the model like, feedback has raised. And then in the refined step, it's very similar, but now you have like let's say input, output, initial draft, feedback, and also like a refined prompt, like which you use for like generating the refined output. And in this case also, it's a few short examples like prompted in the and the next part is like you keep on generating this right until a specific time step and you're like there are two ways, right? One is like stopping criteria can be like some scalar score, right, where you ask the model to generate a score right after each output, and then basically if you're reaching a certain score you just stop. Next is like you can just continue this for any iterations and just stop after it. So depending on like basically what heuristics you use, that might like change the algorithm, but like the termination step. But that is the overall algorithm or the ideas really still remains the same. And now, if you look at the example, right, in the figure two, you have example at the top left, right, or dialog, where let's say user is asking about something, model generates a response. And then based on like let's say some feedback from that you pass to the model, right? Here is the example of feedback that is generated, right? That says that let's say the response was not talking about anything about play, table tennis or how to play it, right? So this response is not like very informative and kind of doesn't answer, let's say, the uh, user specific, let's say, need, right? Like in a way. And then basically after passing in this, like let's say, initial output, input, output, feedback, the refined output is like something like this. So that's great to hear. It's a punch for required input reflexes and so on, right? So now you see that the response that is generated is quite relevant to the input, right? That is talking about table tennis and how to play it or something like that. You know? And similarly, you can see like for code as well, right? So maybe like one example you showed is that you might have, let's say, initially a bit slower version of the code, but then you kind of refine the output to actually, let's say, improve the efficiency of the code and make it faster. So those are two examples. And now if we look at the algorithm, right, like actual core algorithm, basically which just translates diagram one, right, like figure one that we saw. They start with initially like three different prompts, right? One is for generation, one is for feedback generation, other is for refinement, right? And we have a model n, right? And basically input x. Initially, we generate the initial draft, like given, let's say, uh, generation prompt and input. Once you like get an initial draft, then for like let's say n iterations, you generate a feedback. Given the input initial draft and so by initial draft, I mean like the corresponding iteration draft and also the feedback from. And once you get the feedback, based on certain condition, you can decide whether to continue with refinement or not. And if you want to continue with refinement, then you just again pass entire uh, previous history, right, as a concatenated form along with the refined prompt and repeat this process n time. And after, like, once you like complete it for any iterations, you can get the final output, and that's the refined output that you have, which is a bit, which is let's say a much better version compared to the previous, like the concatenated. Any
Just a
questions so
quick
far?
question.
Yeah.
Like, what does the double bar symbol in the
So
algorithm
double
indicate?
bar, yeah. So double bar in this case indicates like concatenation, basically. So you're concatenating like let's say this generation prompt with the input, right? So yeah, just like everything feeding together, like first sound, like if you do it together.
Okay, got it. And also, like, one more thing I
Yeah.
didn't understand completely is the stopping criteria.
Mhm.
Uh, like,
So,
what are the factors that decide the stopping conditions?
uh, so right now, like if you look at in general the generic format, right, this is for the stopping condition. So one would be like, let's say you do it for n iterations, right? And once you complete n iterations, you can just stop it, right? So that's the more trivial way,
Mhm.
right?
Yeah,
Next part is, let's say you might ask the model, right, in the feedback to produce a final output score, right? And you might have certain bounds for the output score, right? And if you hit that particular, let's say, cross the particular output bound, right, or like reach a threshold, right, you can just determine to like let's say exit or not, right, out of this iterative cycle. So those
but
are two different ways. Yeah, sorry, one.
like, won't we have to like have a separate evaluation module in case of things like summary or uh, open generation tasks?
Yeah, so the point is like when you're passing, like doing this feedback generation, right?
Hmm.
So in the feedback generation, right, you're asking the model like what are the mistakes versus like the let's say uh, like that can be improved in the current like output, right? And you can additionally also ask the model, in addition to this, right, out of like let's say like a rating from 0 to 100, right? Rate the
Oh, I
output
see.
that is generated. So basically, if let's say you have some score, right, and if the model says that your score is above certain like threshold, right, then you can also determine the exit, right? Basically, so that's like two heuristics at least.
Got it.
And, yeah, and you can for this score, right, you can ask the model to break it down at different aspects like that you want to evaluate, and then basically just ask it to also produce a final output score. So something along those lines.
Mm. Okay.
So yeah, so if you look at this way, right, this space of context, and I guess it seems like the context would keep on growing, right, expanding this way as you go on iteration one after the other, right? Because you also pass all of whatever history that you have, right, over time, basically, like the past iteration, refinements, and like you did outputs, right? So it seems that maybe this approach is bounded by, let's say, certain sequence length as well, and might not necessarily work well for smaller models. But that's my guess. Because the other models that I tried usually are much bigger context models, so it's hard to like currently generalize that like that. Um, yeah, in that case, it's more like an in-context supervision. So that's the only supervision that you provide, like basically to the partner. There is no other supervision out in the form of training of this. Next for the task, right? So there are seven parts. One is dialogue response generation. So maybe you think of it like you are doing some dialogue or it is some context, right? And you might have to generate some output as context to that, right? Just be like following the dialogue, right? Happening. Next is code optimization. Let's say you have given a piece of code, right? And you want to improve the code so that it's, let's say, it's computation efficient, right? And so this is in terms of computational complexity. And next is also code readability. So, like you are doing some code and you want to improve, let's say, the documentation of the code, right? This is where you like, put comments like about what is happening, better variable names and so on, right? So those practices. Other than that, is in math reason. And next is sentiment reversal. Let's say you're given some review or some text, right, about with a particular sentiment, and you want to flip the sentiment altogether. Maybe let's say, if I have a movie review with like positive sentiment, I want to basically switch generate output with a negative sentiment. Like let's say having maybe semantic, like same semantic, uh, sorry, syntactic, like uh, similarities, right? So that's one. And apart from that, they introduced two different tasks. So one is acronym generation and another is constraint generation. So acronym generation is more like, let's say you might have a very long span of text and you want to generate a, let's say, easy to remember and I guess the, uh, uh, what I would say, relevant acronym with the, whatever the, let's say, full form would be, right? So that's an abbreviation generation you can consider. Next is also like a constraint generation where it's more like a extension of earlier tasks like proposed by Lincoln. But here they impose ideas like constraints that whatever you might have 20 to 30 keywords and you need to produce a sentence out of it, right? This keyword kind of captures all the concepts. So those are the current tasks. We'll see more on this like shortly. And as I mentioned, right, like we see that stopping criteria can be different ways, right? Once maybe you ask them all to generate um, a score and stop it, or like otherwise wait for any iteration. So in this case, they do it for 4 iterations at max. And here the models that they try are all GPT series models. So GPT 3.5 base model, ChatGPT, GPT-4, as well as Codex. So Codex, they just evaluate only on uh, code optimization and code readability. But and for whatever, like let's say there were existing tasks, right? They use the old prompts. But for newer like tasks which are added, they create prompts from there. And if you can now see on the table one, right, it shows the improvements, right? So how much improvement does like let's say self-refined does on top of base model that they use, right? And we can clearly see that in every let's say task there is a good amount of improvement or at least significant improvement, except math reasoning. And this is because the feedback also that might be generated, right? That might not be very uh, helpful, right? In a way to actually let's say improve or at least like figure out the mistakes, right? Because maybe there's some operator like change or at least some number change, and that just kind of makes the model like this is out for something else. Right? So if it is math reasoning is a bit harder task, right? But if it is use the LLM as a way to evaluate it. If you use like some programmable interface, right, where you can just construct a program and that pass the program to some solver, right? And you get some output, right? If you use that, then maybe your models can like do a good job on math reasoning. And for this one, the metrics that they use are standard for whichever task they do that. So like meaning like for math reasoning, code optimization, and constraint generation, there's already predetermined metrics for how many questions did you get right. So percentage solve rate for math reasoning, percentage program optimized. So it's simply like an accuracy proxy for accuracy anyway. And for constraint generation, like what's the coverage, right? And, like where do the how many concepts are covered this week for the case, for example. And for other cases, they do human evaluation, where it's preference-based evaluation. So maybe like you have two different system outputs and you ask which one is better, right? And similarly for GPT-4 also they do preference-based evaluation as well. So using GPT-4 as well, and they find that uh, in both of the cases, human as well as GPT-4, they see like the self-refining is better, and in GPT-4, uh, like it's the correlation with human like the preference is 82% for sentiment reversal, 68% for acronym generation, and 70% for dialogue response generation as well. Like, accordingly. Yeah, I think I was mentioning about, so I'll just skip this part, like getting the categorization text. Uh, yeah, um, so now let's talk about different intermediate ablations and like let's say experiments that are conducted, right? To understand like let's say impact of each component. So first part would be right, like let's say intuitively it might be right that uh, any feedback would be helpful, right? Like why need to have the self-refined feedback, right? This is uh, so first to understand it, like if it is self-refined feedback, right? That is iteration over time and basically generating the feedback, right? Uh, is more useful or not. They do a ablation where they so self-refine in this case means like an actionable feedback, right? Where let's say you know what sort of improvement or like what mistakes to resolve, right? Anyway, so it's not very like high level basically. And generic feedback would be very high level. Right? So those are the two differences, and then there's no feedback at all. And if we see right across code optimization, sentiment reversal, and acronym generation, right? Self-refine consistently outperforms all the other approaches. But it is also clear that maybe any sort of feedback is still helpful. And this performance improvements might vary depending on like let's say different tasks for if you pass the feedback like whether it be self-refined or generic. Any questions so far before I continue? Okay, so I'll move on. Apart from that, right? Next thing is like they right now decide to go with 4 iterations, but you might also want to see right like whether it kind of improves over iterations or like it saturates like particularly, right? And if over iterations, how much is the improvement as well, right? So one thing which is clear, right, is that you look at figure 4, right? Y0, Y1, Y2, Y3, right? If you go from left to right, right, you would see that over iteration, your model output score tends to improve, right? Output quality is better, and that kind of reflects in the final metrics as well, right? So that's one case. But now as we keep
What is the
moving,
unit of
yeah.
measurement?
In this one, I think it's a task metric, right? So as I mentioned here before, right? Like let's say for code optimization is percentage of programs correctly optimized, right? And similarly for sentiment reversal, number of like let's say instances correctly reversed, right? And for the third part, I think this one, right? Like function generation also like percentage of concepts covered, right? So for instances, right? So that's how they do it. It's a similar to an accuracy you can think of, right? Like a scale of 100.
Okay.
Yeah. And if you see, right, basically between two iterations, right, when you improve, like, so compared from Y1 to Y0 to Y1, right? The initial iterations will see the improvements are like, let's say, significant, but over time between iterations, the improvements tend to drop and there's like marginal, let's say, gains, right, over time. But still, those are helpful. So yeah, this anyway increasingly proves that Iterative run just like self-refinement, right? Over, let's say, any iterations, so you have a like, really good impact overall. Next will also like let's say another thing would be right, like similar to this when in chain of thoughts, right? You think about like let's say you do uh, n chains, right? And basically you generate n responses, right? And then if you see like do some max voting or at least some way, right? To figure out which is the best or which responses are aligning, right? So more like generating n different outputs at once, right? At least. So one of the option is like why not just generate multiple outputs and then basically just do some ranking or preference modeling, right? Or some preference based selection, right? Instead of generating let's say outputs uh, sorry, refining outputs over time. And in this case also when they do it, right, they so they in this case like for ablation they generate four different responses from GPT and also like one let's say response which is like a refined version over time over different iterations. And it is clear as per the study, it is clear that basically the defined output is better than the one which is let's say like better than generating four outputs. And maybe let me, let's see. Multiple sets for
Did they also try evaluating it on multi-ton?
now I don't think they try right now multi-ton. So whatever
Mm-hmm.
is right now dialog, it's just taking multi-ton as the input context basically and just generating a single yeah. So if you
So
look at
like,
the slide, you can go on.
oh no, like I'm just like wondering if you would ideally put the whole refined prompts like from Y O to like the D step in the next run, or just the last refined prompt as the input context.
Sorry, could you repeat it maybe once? Like, is that your question like whether you refine all the intended outputs or like just the last output? Like, is that the question?
Now, like my question is that what in the next turn, like what you will feed as the input prompt. So in a multi-turn setup, you generally end up feeding the whole previous dialogue history, right? But
Yeah, yeah.
in self-refinement, you are refining it n times, so you have now n generations in just one
So
turn.
yeah, yeah, it will be like three iterations for one, like let's say if it's a k-turn like conversion, right? And n
Mm-hmm.
iterations for let's say single out for response, right? Then it would be for each iteration we will have to first do n turns, right? Like this is refinement. And then basically once you get that context, you again like then do uh, again like let's say the generation, any refinement, again generation and then refinement, right? So the number of steps would basically 10 times k, right? And that's
Yeah,
complex. So that's too expensive. That's why yeah,
yeah,
like
true.
because the thing is like even if you look at this right, like the output generation, feedback, and response, right? Those are three different steps that are done, right? And ideally later on, maybe over time, I believe like there will be more improvements where maybe we might be able to do everything at once, like step. So we just prompt the model like with all of this, and it does like all this in a step-by-step fashion. But right now, it's not for like the way out. If that's the case, and maybe that might like, make it much easier way out for it on for multi-turn dialogue as well, the conversation.
Right.
So if you can see in this one, right, like I said, the acceptance rate, like it clearly shows that self-refined has an improvement, let's say over the particular system, and maybe in some cases there are time, but yeah, self-refined has definitely has improvement over the base model. You know, yeah. So apart from that, right, like one other thing was like, let's say, can we do this, right? So there are some other works like such as speculative decoding and all, right? So and this the concept is more like, let's say you first generate a draft tokens, right, like in a smaller model, and then use a bigger powerful model, right? To like let's say verify the tokens, right, or at least like do a verification step. And since you can like when you are training the model, right, you can do like all like pass all the tokens, k tokens at a time, right? Uh, and do the computations like in parallel. Basically, that's the same concept. So you basically pass k draft tokens and so a bigger model and basically do all the computations together and like, let's say do it. So at least this is a way to improve your engine speed, right? And uh, like let's say use a weaker model, right, as a proxy to basically just generate simpler each tokens and effects and like just use this bigger model for the conformer. conformational step or like only to generate some like let's say complex tokens, right? So here also it's very similar idea that they want to try or see. So let's say use a Vika model as a draft, initial draft generator, and then basically you pass that draft to some. Uh, okay, wait, sorry. I think that that's something in the appendix we'll cover it shortly. But more like here in this case, it's more the idea is like they want to see if this works well on Vika models or not. So by Vika in this case, it means like let's say the ones which are maybe Llama 1 model, Llama 2 models or something like that, right? Which are much smaller parameter space and and comparatively like poorer than GPT, right? And like by significant number. So they use Beacon or something billion. This is a Llama V1 model, fine-tuned on chat data. And in this case, we observe that at least initial generation is good for Vicuna, but later on when it comes to feedback generation and other steps, right, it often fails to generate a consistent feedback, right? And that's something like a problem with at least most of the open source models that like the generation is not very good if you operate at very small ones, like so yeah, and then the entire refinement process or whatever it be, right? It's a bit more hallucinated process and yeah, you do not like improve or like so so one hypothesis that they have is if you have a model which is not instruction based model or at least specifically trained on conversations or such cases, right? It will not generalize well. To work on like let's say a few subsets like this in context task in text mention. Apart from that, they do some qualitative analysis, and they say that in most of the cases, like the majority of issues are more like due to like let's say erroneous feedback. Maybe let's say model doesn't get the feedback correctly, and this is more often the case in mathematical reasoning at least, rather than actually faulty refinements to be specific. So for faulty refinement, that means like let's say a feedback was correct, but the refinement that was made is incorrect. So usually for successful cases, also they see that if the feedback is more accurate and precise, then model can make necessary changes in the output as well. So yeah, that's more like a cascading effect, right? I think. Apart from that, they also try like real world use case, like let's say website generation, where you might have some abstract concept at the start, right? And you will probably do a skeleton, and then over time you will just improve and basically um, let's say layout and all, right? Like it's similar to, for example, you'll first have this like a raw HTML code, right? And then you'll add CSS and so similar to that concept, right? So you're effectively improving the website over there. Iteration. Any questions so far? Okay, I'll and next we're looking at the comparison about let's say different like approaches that are existing and self-refined. So the comparison across four axes. One is like let's say there is some supervision pre-refinement, which means like it doesn't need any supervision or let's say training to refine the outputs. Next one also is the supervision free feedback where uh, you don't explicitly need like to fine tune the model on feedback or it is something like that. Third is the multi-aspect where it can let's say score or like if it improve across multiple aspects. And fourth one is iterative where the idea again is like whether it is just a one-shot refinement or an iterative refinement. And there are just two categories. One is your learned refiners and the other is prompted refiners. So learned refiners are the cases where you let's say have some model which takes in input whatever your intermediate output would be, and then just generates like a new output, right? So it's using another LLM basically, basically to do this refinement stuff. So it's like a post-education, like a model basically. Prompt refiners are the cases where you just tune the prompt or at least like cases, right? Like this prompt tokens or at least raise, right? So basically let's say steer the model. Third is self-refined, which like basically as we discussed like right now. Right? So that's one of the keys. And you can see that like self-refined supervision free uh, from even for refinement as well as for feedback generation. Make sure it's also multi-aspect. It can generate like multiple multi-aspect feedback. Like and so it is also iterative over like let's say so you can pass like previous history and like improve the model outputs. One of the limitations right now, right, with this particular work is uh, that it uh, it relies on the assumption that whatever the base model that you're operating in, right, it's a very strong base model which can do user prompting very well, or it will have some instruction following abilities, which it can use to actually, let's say, like use this demonstration style that you pass in context, and so like generate similarly like feedback and refine like outputs, right, basically according to policy test example. So that's one piece, and yeah, but maybe later on, probably like future work may should focus more on also seeing if we can do it in a zero shot fashion, and also if it needs a GPA, it can work well with smaller and weaker models as well. So these are all the evaluation tasks and example. So sentiment reversal as we saw, right? That's a review, rewrite reverse to reverse the sentiment. And it is a task with hundred review passages and this is some introductory like starting snippet like for reference purposes. Similarly, we have dialog creation, which has like 372 conversions and we need to produce rich conversion responses. Code optimization where like it's a Python programs and we need to improve the efficiency, code efficiency, right? So and that's a thousand programs. Code readability is another data set like Python based data program data set where you have to refactor the code to actually improve the readability. And it's 300 programs. I think mathematical reasoning, it's some mathematical questions related to solving mathematical, let's say, problems and reasoning skills, approximately 1,300 questions. Similarly, academic generation is a task that they introduce, and it's a task of 250 academic input. And similarly, constraint generation has 200 samples, and there is the idea is you need to generate sentences based on certain keywords. Yeah. So the closest work which they have, right, with respect to um, is self-correction, where the idea is it trains the refiner with a supervised setup, and that refiner basically let's say takes in the input ground, input output, like let's say the generated output, right, initial output, and then there's a refinement. So that's one of the differences to these like prominent differences approach. And yeah, more details are replaced like about different approaches on like at least like whether they operate in zero or few shot, as well as like whether they are multi-aspect or critics, whether they are localized or language free natural language feedback, etc. are shown in the table for yeah. So you can check out the table for more details. Similarly for human responses as well, where like out of let's say different samples, they see that on 75% of the time humans prefer self-refined outputs, 21% time it's direct output that are generated by the model, and 3.5% is either like pie between them. So, and similarly, you can see for other tasks as well. The self-refined uh, does one. And this is how the prompts are there for evaluation. Uh, yeah. So for example, like let's say in sentiment reversal, right? You start with which review is aligned with the sentiment and pass the sentiment, and then you pass two reviews and whatever the review text is, and then you provide some, let's say, um, context, right, for the model to actually really evaluate and give it its explanation. So, like, pick your answer from all the choices, and then generate a short explanation for your choice, and then generate like some template, right? Like the more aligned review is A, or B and so on similarly. So similarly, there are prompts for also acronym generation and dialogue response generation as well. I believe this is the first thing. Yeah, so this is what I was talking about previously. Uh, so the idea in this case is you use Bitcoin as a additional model, but then use GPT as a way to like let's say generate feedback and like do the refinement stuff. So in this case, they try this, and I guess they saw that even if you use become a certain billion as a base model, and then after that, like using the post that GPT for feedback generation as well as refinement, you see an increment of 24% on math reasoning and also 40%, sorry, yeah, 24% on this math reasoning and 40% in mixed refinement settings, basically overall across tasks. So you can clearly see that this approach is very helpful. Yeah, if you use weaker model in conjunction with a strong, let's say, model for feedback and response generation, all this is like done in intense mode. Any questions so far? Okay, I'll move it. And these are some example outputs which are showing like how we can also are not correct like it is when it let's say does this refinement and feedback generation with the same model instead of ChatGPT. Yeah. So these are I think more like fine details won't go into interest of time. And one of the other things that they see is like when you for dialogue response generation, the errors highlighted are possibly for improving feedback handling mechanisms, like more like interpretability and understanding of user inputs. And next is also like this enhances the let's say model refinement techniques, like by providing accurate and free specific responses. So that's one advantage of like this refinement process going forward. And this is an example of the generating website. So where let's say initial ChatGPT or GPT-4 generates this layout, and then this is how the feedback is generated, and similarly uh, the refined output looks like. So you see that the refined uh, outputs are much better than the initial generated outputs. And yeah, they also report the confidence intervals as well as statistical significance. And it can be seen that in most cases, self-refined is significantly better than the base model. Mm, yeah, I think common gen as mentioned, right? Constraint generation part where I think I already mentioned it's a like generate sentences from different concepts. And in this case, they make it harder by having a constraint of like generating like less than sentence based on 20, 30 concepts. And acronym concepts more like generating acronyms like uh, which are let's say easier to pronounce, like also easy to understand, relevant as well as length trade-off as well, right? So yeah, so question on this one more interesting thing is there in more of a code readability, right? So this is a plot, right? Figure 11. You can see like first is meaningful variable names. Whether like let's say when you ask a model to define their code snippets, whether it's able to add meaningful variable names or not. Next is also like let's see whether it adds comments per line or not, and also like whether the functions that are there, right? So those are more modularized or not, right? And you can see based on different temperature values and iterations, right? The trade-off between this and like how model tends to improve it. So that's how, and it shows that P equal to 0 is more like a deterministic way. So maybe like doing some non-deterministic behavior definitely tends to be, or at least sampling the processes are better than those non. Yeah, I think those are more detailed prompts like for how to actually generate the feedback as well as the refine. ask for refining. So we probably skip this for now. Yeah, I think that's actual paper for more details also. Yeah, but overall, I think yeah, the idea is pretty interesting and yeah, simple as well at the same time. Any thoughts? Any questions you guys want? I'll stop sharing. I believe then maybe we can end the.